Lesson 92 today is about expanded notation with exponents, order of operations, and power of fractions. Now, to begin the lesson, we need to review powers a little bit. 10 to the first power, that's just equal to 10, because 10 is 10. If we have 10 to the second power, we get 100, because 10 to the second power, or 10 squared, that means 10 times 10. And we know 10 times 10 is equal to 100. 10 to the third power, well, that's 10 times 10 times 10. And working with powers of 10 is nice because the number of zeros that you're multiplying here, 1, 2, 3 zeros, tell you how many zeros will be when we expand our number out and what our power will be. So 10 to the fourth is 10,000. 10 to the fifth is 100,000. And if we had 10 to the, well, let's say we had 10 to the ninth power. 10 to the ninth power, that must be, well, a 1 with 9 zeros after it. So we'd have a number of 1 billion when we have 10 to the ninth power. These patterns are nice to know, and they help us when we're writing out expanded notation with exponents. Let's look at an example. Here we have the speed of light is about 186,000 miles per second. Write that number in expanded notation using exponents. So what we're going to do is we're going to write in expanded notation. So we're going to say, what place value is the 1 in? What place value is the 8 in? What place value is the 6 in? Everything else is a 0. So we're going to have 1 times, well, the 1 is in the hundred thousands place, so we're going to have 1 times 10 to the fifth power. Because 10 to the fifth power must be 100,000. Then to that we're going to add, well, we've got 8 in the 10,000s place, so we're going to have 8 times 10 to the, well, if it's in the 10,000s place, we must have fourth power. Then we have plus 6 times, we've got the 6 is in the thousands place with 3 zeros after it, so we're going to have 10 to the third power. We don't need to write out any of the zeros because there's 0 in those place values. So we've got our final answer. Whenever we do this, we want to make sure we're using our exponents in order to help write out in expanded notation. Let's look at our next problem. The next part of the lesson is looking at order of operations, and we know parts 3 and 4 already, that we always want to multiply and divide from left to right and add and subtract from left to right in that order. But we also have problems that will have parentheses in them, and we always want to simplify within parentheses first. Then we want to simplify powers and roots. Then we want to multiply and divide from left to right. And finally, we want to add and subtract from left to right, always in that order. Please pause the video now to make sure you get this in your notes. Let's look at a couple examples. Here we want to simplify. 5 minus 8 plus 8 divided by the square root of 16 plus 3 squared times 2. So our first step, if you look in your notes, what's the first step? Well, the first step must be everything within parentheses. So we're going to say 8 plus 8. That's 16. We're going to get 5 minus 16 divided by, next comes simplify powers and roots from left to right. So the square root of 16, well, that must be 4, because 4 times 4 is 16. Then we've got plus 3 squared, well, that's a power, so we need to simplify that next. 3 squared, 3 times 3, that's 9, times 2. Now we can go ahead and multiply and divide from left to right. So 16 divided by 4. 16 divided by 4. That has to be our next step. And then following the division, we're going to multiply because we multiply and divide from left to right. So let's do those. We're going to get 5 minus 16 divided by 4. That's 4, plus 9 times 2, because we multiply before we add, we're going to get 18. Now when we add and subtract, we always go from left to right, just like we read a book. 5 minus 4, that's 1. So we're going to get 1 plus 18. That leads us to our final answer of 19. Key part whenever we work with a problem that's dealing with multiple order of operations is to do everything in parentheses first. then powers and roots from left to right, then multiplication and division from left to right, then addition and subtraction from left to right. Let's look at another example. Here we have to simplify. We have 2/3 squared. Well, all we have here is a power, because everything in our parentheses is already simplified. So 2/3 squared, well, that just means 2/3 times 2/3, because we're multiplying the number by itself. So 2 times 2, that's 4. And 3 times 3, well, that must be 9. So we've got our final answer. Our final answer must be 4/9. Whenever we square a number, we're always just multiplying it by itself. Whether it's a whole number, a fraction, an integer, or a decimal, always we're going to multiply it by itself when we square. Lesson practice will be on page 496. Make sure you've got your notes complete, and I'll see you during our next class.